Telenor is transforming their networks towards NFV and SDN in order to achieve gains in agility, service delivery speed, new service opportunities, and operational efficiency. NFV orchestration is perhaps one of the most key components to achieve these gains. However, NFV orchestration is also among the least mature parts of the NFV architecture. When open source Mano was established, Telenor did this primarily because of two reasons. One was to contribute to move the industry towards common and standardized solutions and models for NFV orchestration. The second was to gain competence by working together with organizations having a lot of competence in this area.
When we think about 5G, it creates a lot of new business and service opportunities, and really underpinning those is the need for a very flexible, a very scalable infrastructure and a very capable network of supporting multiple different types of services. The network needs to be capable of responding to those new service categories and allow them to be implemented in ways that we have really never been able to do before. And underpinning a lot of that is this move toward function virtualization, or software-controlled networks, or software-defined networks.
At Rift.io, we are committed to helping the mobile and fixed service provider community accelerate the adoption of SDN and NFV. We're focused on orchestration and automation, and we're delighted to be participating in the 5G network slicing demonstration with Telenor and our key partners in the ecosystem.
We foresee, and we work a lot with their transformation of their operational systems so that they can achieve this DevOps capability and this agility that they will need for their future service and business. And today we see this starting with network virtualization, but that's just the first step. The second step, which we see starting to happen now, is what we call the service cloudification, where their entire business is transformed into a cloud business model, where operators sell and produce services completely automated. So we hope to be part of that journey and helping operators to move ahead.
We're here to demonstrate a joint PoC that we have done, where we show how virtual testing can be introduced in network slicing. Netrounds provides virtual test agents that are being orchestrated by Rift.io or open source Mano to capture KPIs specific for various service chains. Okay, so before we get into the live demo, let's have a high-level view on the contents of this PoC. From a high-level perspective, the PoC contains of two products and solutions. One is from Rift.io, the orchestration part, and the other part is from Netrounds, the test orchestration. Here we have indicated two different components. One is the network service descriptor for the first of the slices, and then we have the corresponding test and measurements that are associated with the first slice. This can be generalized to contain three different slices, which we will showcase shortly. Slice 1, 2, and 3. These three slices are designed and are tailored for different attributes and to meet specific KPIs. But important here is to keep in mind that each slice has its corresponding test and monitoring templates, both for activation testing, but also for ongoing assurance. Rift.io will instantiate Netrounds virtual test agents, VTAs. Those VTAs are a critical component of each individual slice. So using OpenStack as the virtual infrastructure management layer, Rift will deploy virtual test agents on strategic locations as part of the network service chain. Netrounds Control Center will then coordinate the test activities to capture the active SLA metrics. We have three different slices: broadband, massive IoT, and industrial. The first is optimized for throughput, the second for packet loss, and the third for latency. In order to capture those KPIs, a key characteristic is here to insert virtual test agents as part of the service chain, but also in various locations in the traffic path. And this is what we're going to showcase shortly. When we enter the demo, you will see Slice 1 and Slice 3 already instantiated, and Noel will take you through the OSM Rift dashboard to see when we instantiate dynamically Slice number 2. Let's see some live action.
Hello, we will start off where Mats left off. So we are at the OSM UI that showcases the composer view of the orchestration. And from here, we go to the network service descriptor, which kind of takes you through actual creation of a network service that you see in this picture by bringing in the VNFs in the catalog via VNFDs. And what you see here are the constituent information related to a descriptor that captures not just the essence of the service itself, but also the components related to service primitives, packet monitoring, tests that needs to be run once the services are up and running, etc. What you see here are Slice 1 and Slice 3. We will be instantiating Slice number 2, which is massive IoT. So from here, our next process is to go to the dashboard. And once we go to the dashboard, you will see the components related to instantiation. If we look at Slice number 2, you will see it in a configuring state. So before we were seeing Slice number 2 in an init state, now you can see it slowly coming up, which is in configuring state. So the idea of the orchestration is not just launching individual VNFs, but the idea is to launch a network service and launching the whole service from start to the end, where you configure, you get the automation going so that the VNFs come up, get configured, and all the tests that are associated with the primitives are all run as well. What you see here now, Slice 2 has become active state, which means the orchestration has completed its part of orchestrating and instantiating the whole network service that we saw earlier, and it's now in an active state and ready for starting of the monitoring test cases. So Matt is going to take over from here and kind of show you through starting off testing, as well as some of the responses on the Netrounds page that you will see.
Okay, so Noel showed how Slice number 2 was instantiated. Now we're back in the Netrounds dashboard to see the birth certificate and the activation testing of Slice 2. Remember that Slice 2 was for IoT devices. So here we have now automatically executed a predefined, pre-built template tailor-made for IoT. So this is a test that has been automatically executed from Rift.io. We can even get a birth certificate report being pulled back over the API back to Rift if that would be needed, and stored as one part of the service activation. Now what remains is to enable the ongoing assurance. So going back to the Rift dashboard, we will open up the viewport of Slice 2. As you can see, there were no numbers showing in the live KPIs yet. That's because we haven't enabled the ongoing assurance. One of the service primitives that Noel showed was the primitive for enabling active monitoring. These are now two examples, just showing two parameters being fed as input as part of the network service descriptor. The most important one is the reference to the template ID. This is a template that has been pre-built in Netrounds controller. Rift will now reference to that template ID, and when I click submit here, Netrounds controller will get the service primitive parameters, and it will execute the corresponding template. Now we see that Slice number 2 monitoring is started. So if we now switch back to the Netrounds dashboard, we will now see the two first slices up and running already, Slice 1 and 3. Number 2 is the one that we just recently initiated. As you can see now, this is gray, meaning there is no data. So new data will automatically appear sliding in from the right in this time window. These are the 15 last minutes of the lifetime of the service. We can now see green is starting to appear. Netrounds is calculating error seconds, which means that if there are any of the thresholds that has been specified, if those are violated, those will be detected and those will be reflected back to OSM. So OSM can take action for either redeploying or taking actions on that specific network slice. So the service has now been properly activation tested, and we now have full real-time visibility into this specific slice and the other slices as well. So that concludes the demonstration.